Hello everyone, this is the fifth part of the chapter, reactions at alpha carbon of carbonyl compounds. And in this part of the chapter, we are going to talk about enamines. I hope that you guys have a good understanding of what are enamines. Enamines are compounds which are obtained by reacting a carbonyl compound, specifically an aldehyde or ketone, with secondary amine. So maybe we'll do an example here. So this is a ketone. When you react it with a secondary amine in the presence of little amount of acid, maybe trace amount of acid, we will get the enamine. Again, enamine has a double bond, a carbon-carbon double bond, and a carbon-nitrogen single bond. Okay, and along with that, you will also have some amount of water liberated. Okay, now what are the reactions of enamines? Enamines react with electrophiles in the same way as the enolates do. Okay, so how does the enolates react? So enamines react in same way as enolates. Okay, so here is the structure of enolate, and we know that the enolate can act as a nucleophile on an electrophile. So these electrons come in here, and this is going to go attack on the electrophile, giving rise to this product. Okay, so this could be an alkyl halide. Okay, in the same way, enamines can react with an electrophile. And the mechanism is going to be exactly the same, but there might be one additional step here to recover the carbonyl compound. So these electrons are going to come up here, and it's going to give this product. So to get the product, you will actually hydrolyze it, react it with water, and you will get the carbonyl compound back with a substitution on it. Okay, so here is the enolate. This is for enolate, and this is for enamines. So this is also a good way to alkylate aldehyde ketones at the alpha carbon. Okay, how does alkylation of an alpha carbon occurs via enamine? Okay, again, the first step is going to be the formation of enamine. So you take a carbonyl compound, react it with a secondary amine, and then get the enamine. And the next step, you react it with an alkyl halide, followed by hydrolysis. Okay, so this is an amine reacting with trace amount of acid, and you synthesize the enamine. And when you want to react it with an alkyl halide, these electrons are going to come up here, and this is going to act as a nucleophile and thrust those electrons onto bromine, so it can be a good leaving group. And again, this reaction is an SN2 reaction, right? Remember, alkyl halides can undergo nucleophilic substitution reaction, and since this is methyl bromide, which is not statically hindered, it cannot definitely form a carbocation, so obviously it has to undergo SN2 reaction. Okay, so once it is formed, the imine Remember, imine is a compound which has a double bond between carbon and nitrogen, right? So this is an imine. So after it has formed the imine, it's going to react with, or you're going to hydrolyze it with water in the presence of little amount of acid, and it is going to break the bond between, or it is going to form the carbonyl compound with the substitution on it. And you will get back your secondary amine that you used for the reaction. Okay. So because alkylation is an SN2 reaction, only primary and methyl halides should be used for this reaction. Now, in the next slide, we are going to talk about the advantages of using enamine intermediate. Okay. So the first advantage is it forms only monoalkylated product. Okay, remember, in the case of hydroxide ions, when you used hydroxide as a base, it formed like mono, di, tri, and tetra products, right? But here, if you're going to use enamines, they are going to specifically give you only monoalkylated products, because this is going to be a great advantage in place where you cannot use such a strong base such as LDA. Okay, so again, this is another example that we are going to do. And you can also do the acylation of the carbonyl compound. So for this, you're first going to convert the carbonyl compound into an enamine. So here is your enamine, and you react it with the acyl chloride. Here it is acetyl chloride. So instead of using alkyl chloride or alkyl halide, you can also acylate a compound, a carbonyl compound at alpha position. Okay, and the first step is, again, it's going to behave more like an enolate, and these electrons are going to go and attack the electrophilic carbonyl carbon, and those electrons will go on to oxygen, and it's going to give you this intermediate, which is called as amine, with the substitution at the alpha position. Now the electrons on oxygen is going to come up here, and the leaving group, because it has got a leaving group, the leaving group is going to leave. Okay. I guess you should be able to predict what would be the next step. Yes, that is hydrolysis. Okay, so the hydrolysis is going to convert this part of molecule into a carbonyl compound or carbonyl group. Okay, another advantage of enamine is the reaction between an alpha carbon and alpha beta unsaturated carbonyl compound. So probably we'll do the reaction, we'll draw the structures, then we'll be able to analyze like what's happening. Okay, so we want to react, a carbonyl compound. Here it's ketone with an alpha beta unsaturated carbonyl compound. Okay, so here it says this particular application is going to connect the alpha carbon of the carbonyl compound and the beta carbon of the alpha beta unsaturated carbonyl compound. So let's just label this one. So this is the carbonyl compound, which is specific ketone, And here is your alpha beta unsaturated aldehyde. Now let's find the alpha carbon on the carbonyl compound. So it would be this carbon. And what would be the beta carbon on the alpha beta unsaturated aldehyde? So if this is the functional group, then this is going to be our alpha position and this is going to be the beta position. So this particular enamine is going to make a connection between this carbon right here and this carbon. So let's see how it happens. Okay, so the first and foremost thing is you wanted to convert the carbonyl compound into an enamine. Okay, so that would be the first step. So let's do it here. The carbonyl compound should be reacted with secondary amine in the presence of trace amount of acid to give the enamine. That would be the first step. So once the enamine is created, the enamine is actually going to act as a nucleophile onto the beta carbon of the alpha beta unsaturated aldehyde. Okay, so this is the structure of enamine. Okay, and we draw the alpha beta unsaturated aldehyde. Okay, these electrons are going to come up here, and remember this is going to act as a nucleophile attacking the electrophilic carbon of the alpha beta unsaturated aldehyde. Okay, maybe I'll label it here. This is alpha, this is beta, and this is your alpha carbon here. Okay, so in this step an imine is formed. Okay, and remember the alpha hydrogen is now substituted for the alpha beta unsaturated aldehyde group. Okay, so when these electrons are going to come up here, this is going to hop here and the electrons will go on to oxygen. And now when you have some water molecules, this is going to go here. And by forming the product. Okay, remember the last step would be the hydrolysis for converting the C double bond N into C double bond O. Okay, so as you can see from here, the alpha carbon of the carbonyl compound is actually connected to the beta carbon of the alpha beta unsaturated carbonyl compound. So this is one other application of enamine.